students, welcome back to this tutorial. In this video, we can discuss about the conversion of decimal number to its octal equivalent form. In our previous video, we have already discussed how to convert a decimal number to its binary form and also the conversion of a binary number back to its decimal form. So following the same method, here we are going to convert decimal number to its octal form and also converting octal number back into its decimal form. Okay. So here we have one example. For converting decimal to octal, here considering a decimal number 1024. Now we can convert this 1024 into its octal equivalent form. For that, what we want to do? We want to divide this 1024 by this base 8. Okay. So while dividing, we get a quotient 128. So write that quotient here and write the remainder here. Then again, divide this 128 by the same base value 8. While dividing, we get a quotient, write that quotient here and put that remainder here. Repeat again, divide the 16 by 8, we get a quotient 2 and remainder 0. Now this quotient become less than our base value, so we can stop right now. Okay, then arrange this number in this order. So this one is our octal equivalent of 1024 in decimal. Okay, the 1024 in decimal is equivalent to this number 2000 in octal. Okay. Now we can consider the reverse form. How to convert an octal number to its decimal form. So what was that method for converting this? We need to identify the positional value, then multiply and add up values. So here it is the number 2000 in octal form. Now we want to convert back into its decimal form. For that we need to first identify its positional values. Okay, then multiply with these values and add up these values together. 0 into 8 raised to 0 is 0 itself. 0 into 8 raised to 1 is 0. 0 into 8 square is again 0. And this one is 2 into 8 cube. 2 into 8 cube is 512. So 2 into 512, that is 1024. So in octal 2000, which is equivalent to 1024 in decimal. For converting octal number back to its decimal, what we want to do? We want to identify the positional value, then multiply each digit or the symbol present at different position with this positional value, then add up these values together and get the decimal equivalent here. Okay. Now we can consider another variation. That is how to convert a fractional number to its octal form. Okay, so following the same method that we have discussed in our previous video. But here 8 is the base value. That is the only one difference. Okay, for converting an fractional number to its octal equivalent, we want to perform this. 0.25 multiply with this base value 8. So while multiplying, we get 2.0. So this 2 is the whole part and 0 is the fractional part. So focus on this, kept this whole part here and focus on this fraction. But here the fraction contains only zeros. Okay, if the fraction contains only 0, we don't want to proceed further, we can stop right now. Okay, and arrange this whole part only in this particular direction. So this 0.25 in decimal is equivalent to 0.2 in octal. Okay, here the fraction become full of zeros here. So we don't want to proceed further this multiplication. If this fraction contains non-zero values, then we can stop here. We want to multiply this fraction again with the base value 8 and repeat again and again different number of times and arrange this whole parts in this particular direction. So here the fraction, fortunately the fractional part become full of zeros, so we can stop here and arrange this whole part in this direction, and 0.25 in decimal is equivalent to 0.2 in octal. Okay, so consider one more example. So before that, just consider the reverse operation. 0.2 in 8, we want to convert back into its decimal form. So for that, what we want to do, in case of this fractional value, for converting back into decimal, we want to multiply this number or this symbol comes just after this point or this decimal symbol. Multiply this 2 with 8 raised to minus 1. 2 into 8 raised to minus 1. If we have more digits here after this decimal point, then the first digit is multiplied by 8 raised to minus 1 and the next number multiplied by 8 raised to minus 2 and so on. Okay, here we have only one digit just after this decimal point, so we can stop here. That is 2 into 8 raised to minus 1 alone here. That means, what is this 2 into 8 raised to minus 1, which is 2 by 8. This 2 by 8 is 0.25. So which is exactly equal to this number in decimal. Okay. Consider one more example. Here we have 120.15 in decimal. Convert this into octal form. Okay. For that, consider the whole part separately and the fractional part separately. Right? So while considering this whole part, what is the method for converting this into its octal form? Division. Division by this base value 8. Okay. So 120 is divided by 8. Get a quotient of 15 and a remainder of 0. Again this 15 is greater than this divisor 8. So repeat the division by 8, then it gives quotient 1 and remainder 7. Now we can stop here. Why? Because the quotient now become less than this divisor 8. So we can stop right now and arrange these values in this particular order. So the whole part octal equivalent is 170. So this is not the final answer. We need to consider this fraction also. So for converting this 0.15 into its octal equivalent, we can consider the multiplication of this 0.15 with base value 8. So while multiplying, it generate 1.2 and keep this whole part there and multiply this fraction again with base 8. It will generate 1.6. Again multiply the fraction with the base and generate 4.8. Okay, this 0.8 is multiplied again with this base 8 and generate 6.4. This 0.4 again multiply with 8 and generate 3.2. Now it is clear that here the fraction now become 0.2. So the further multiplication, it generate the same pattern. 0.2 multiply by 8 generate 1.6. So it will repeat the same product value. Okay, 0.2 into 8 generate 1.6, the same 1.6. So if we are going to continue this multiplication, it will repeat the same pattern. Okay, so we can stop here and arrange the whole numbers, the whole part of this product value in this particular direction and generate the octal equivalent of 0.15. But if we need more and more accurate, exactly equivalent octal equivalent for this 0.15 in decimal, we need to consider more and more product values. Okay, Now I'm going to stop here and arranging these all values and get a fractional equivalent of this 0.5 in octal as 0.114631. Okay, so the exact octal equivalent of this 120.15 in decimal is 170.114631. Okay, so next we can consider how much it is accurate with this value 0.15. Okay, for that consider this value in base 8, the conversion back into its decimal form. For that, what we want to do, we want to multiply this one with 8 raised to minus 1 plus this 1 into 8 raised to minus 2 plus 4 into 8 raised to minus 3 plus 6 into 8 raised to minus 4 plus 3 into 8 raised to minus 5 plus 1 into this 1 into 8 raised to minus 6. So this one means 1 by 8 plus 1 by 8 square. 1 into 8 raised to minus 2 by 1 into 8 raised to minus 2 means 1 by 8 square, that is 1 by 64. Plus 4 into 8 raised to minus 3 means 4 by 8 cube, that is 4 by 512. So this one is 6 by 4096 and this one is 3 by 32768 and this one is 1 by 262144. So after division we get the fractional values like this. And while adding these values together we get a result 0.14999,389 which is very closer with the value 0.15 in decimal. Okay, so from this it is clear that if we are considering these much product values, then we get a result like this. A decimal equivalent, that is 0.14999,389, right, which is very closer with the value 0.15 in decimal. If we need more and more accurate result, or if we need the exact equivalent 0.15 in decimal, what we want to do, we want to consider more and more product terms. Okay, so all these are about this conversion of decimal to octal and octal to decimal. Okay, thank you.